shift gears from probability into analysis and statistics. In analysis and statistics, we're going to be able to understand and explain some different ideas, such as collecting data, variability in the data, and how it's going to relate to the study of the numbers, a difference in a survey population and a sample population, and a simple data analysis method and interpretation that can be used across all grade levels. Much of the study of statistics deals with what we call variability of data, or how much the data varies from one sample person to another. That's also the amount of pieces of data in a data set can differ. So we're looking at how much can it vary in reference to each other. And we're also looking at, well, how much does it vary with the amount that I gathered? It's important to understand these two different types of variability when we're designing experiments and examining data. When we're asking measurement variability, suppose I ask 20 students to give me a measurement for a board. In a perfect world, all 20 students would measure exactly the same. However, as we know, students are going to get slightly different answers because they may have to estimate a little bit, or maybe they don't put the ruler all the way at the end. And so simple human nature is going to lend to the fact that we're going to get some different results. So those measurements are going to vary somewhat between each student. Any two individuals have differences, even genetically identical twins. So no matter what we do, our eyesight is different, who we are is different, how our brain works is different. So we're going to see that come through in data sets with statistics. Induced variability is frequently looked at to see how an individual's reaction to a stimuli is going to change or differ. So this is kind of like the experiment you do with your classes on the bean plants and how they grow based on giving every plant a certain amount of food, water, and sunlight. Some are going to flourish a little more, some are going to flourish not as much. So we're going to see some, again, variability there. Sampling variability then is going to be looking at the sample set and maybe seeing how they react to a question, because you could react in a lot of different ways. So one person may react on a Likert scale of, say, like 1 to 5, when we're asking, on a scale of 1 to 5, how do you feel about math, with 1 being extremely confident and 5 being not confident. Different people are going to have different reactions, and that's going to cause them to give different answers. So that's one form of variability. It's also going to be variability because we're using that sample to represent the student population. And so sometimes, let's say we go in and we sample the honors math class. Is the honors math class going to be a good representation of math students in general? Well, no, because they're naturally going to feel more confident. So when we talk about sampling variability, it's looking at how we're sampling, who we're selecting, and making sure that it's going to be an unbiased result, or as unbiased as we can be. So when we're looking at statistical information, especially with our elementary students, we're teaching them how to think. We want them to think through numbers. So what we're really asking them to do is to formulate some good questions, then collect some data on those questions and look at the numbers. What can you decide? If the plants grew more when you gave them an extra milliliter of water, what does that tell you? So we want them to analyze the data and interpret those results. It's really a thought process. When we're formulating questions, this is going to be any given problem where data can be gathered together to determine either an answer or an approach to an answer. So either we're looking for how much water should we give the plant, or maybe we're looking at when should we water the plant, which is more going to be an approach. It's important that the problem is clarified to the extent that meaningful data can be collected. So you have to have a really specific question where you're asking for one thing, one data point. We don't want to get complicated questions. So one thing at a time. So does giving an extra milliliter of water affect the growth of the plants? And then when we collect data on the appearance, we want to make sure we're coming from a valid group. We're pulling a valid group of people together that represent. So if I'm collecting data on the average fifth grader, well, you're going to have to clarify, what does that mean? Who is the average fifth grader? Is that students with a C or better? Is that a certain height? Is that a certain score on a test. So you want to be very clear with your word choice there as well. Here's an example. The I Am Reliable polling company plans to conduct a survey of college students to determine their favorite movies. What are some survey methods that could be used to obtain the information from the students? Well, you're going to get a lot of different answers. One possibility might be to randomly select students. We always want to randomly select things whenever it's possible because that gives us the best representative group of people. But maybe that's not possible for us. So maybe we're going to get a list of movies, and instead of asking a student, we're going to present this and we're going to pick random people to rate them from most favorite or least favorite. So we're still getting that random aspect in there. But instead of saying, hey, what's your favorite movie? Which it might take a while to get that answer. Now we're saying, well, look at these movies. Which ones do you like more than the others? So those are multiple ways to approach the problem depending on what you're trying to ask. The next step would be after we've gotten a question in our mind, we formulated a question, we have kind of an action plan, we're going to need to gather that data. So immediately we're going to ask, well, who are we going to gather this data from? That context is going to be really important. Once we get that data, we have to make a decision about how to display it. Maybe it makes a really good bar chart. Maybe it makes a really good circle chart. Maybe we just need to report the numbers themselves. Often, the decisions for how to analyze data is going to be made once you're looking at it. However, you can do this in the planning process as well, but definitely take a look at it after you've collected the data and ask your students once they're seeing that data, ask them what's the best way to represent this because it might be a little different than the planning process. Once we get to interpreting the results, this is clear cut sometimes. Like if I give the plant an extra milliliter, they all increase growth. Well, that's clear. I need to get the extra milliliter. But other times it may be somewhat murky, right? So the interpretation that happens really has to be related to the original question itself. So you want to make sure that when you're interpreting those results, we're going back to that original question and we're trying to say, what do these numbers mean in the context of that question?